right, day 3 notes of Unit 1. Here we go, 1.3, graphing quadratic equations. So we're going to graph quadratic equations and we're going to find the parts of a parabola on a calculator. So a quadratic equation is in the form ax squared plus bx plus c equals 0. You'll notice the difference between linear and quadratic is that it has this x squared term. So you have to have a number in front to make it a quadratic equation. Otherwise, it's linear. So the graph, when you have x squared, makes a parabola. If the number in front of x squared is a positive number, it's going to open up. If the number in front of the x squared is negative, it's going to open down. Your vertex can be found by the equation negative b over 2a, comma y. This will be the maximum or minimum point in your graph. So in this case, my vertex is negative 1, comma 2. So that's the maximum point on this curve. For your axis of symmetry, it's the equation x equals negative b over 2a. It's an equation of a line because it is a line of symmetry. So it's the line that folds the graph in half and it goes through the vertex. That's why this is the x coordinate in the vertex. So again, if you look at the graph, this is my axis of symmetry. It goes through that vertex. Notice the coordinates of the vertex, the x value is negative 1, and the equation of the axis of symmetry is x equals negative 1. For your y-intercept, it's 0, comma c. 0, comma c. So if your a and b value are times 0 for x, your c value will be the remaining number. So whatever the c value is, that's your y-intercept. So looking at this graph, where it crosses the y-axis is right here at y-intercept of 1, but technically they should say 0, comma 1. Your x-intercepts, mathematicians couldn't decide what the heck they wanted to call this, so they call them x-intercepts, but they also call them roots or zeros or solutions. All of these basically mean the exact same thing, which is where does it cross the x-axis? So when I do this, my x-intercept is a point, x comma 0, where you set y equal to 0. You'll have to factor that and solve. So in this graph here, you can see where it crosses the x-axis is here and here. So this should technically say negative 2.4 comma 0 and 0.4 comma 0. So this one has two x-intercepts. So for number 1, it says to find the following values and then graph. So we want to label our ABCs. The number in front of x squared is your a value. The number in front of x is your b value. And then c is the number by itself. So starting by finding the vertex, you're going to figure out what the negative b over 2a is. So when we plug this in, it's going to be negative of 6 over 2 times a is 1. So negative 6 divided by 2 is negative 3. Now that you know the x coordinate of your vertex, you have to find the y coordinate, which means you have to plug this number back into the function. So you're going to get negative 3 squared plus 6 times negative 3 plus 5. So this would make a positive 9 minus 18, which is negative 9, and then plus 5, which would make negative 4. So the coordinates of the vertex are negative 3, comma negative 4. Remember that your axis of symmetry goes through the vertex. So since the x-coordinate of my vertex is negative 3, the axis of symmetry is x equals negative 3. To find the x-intercepts, you have to set y equal to 0. But before we do that, let's plot the vertex, and then we have our axis of symmetry. That's all I have so far on my graph. So I need to find my x-intercepts. If I let y equals 0, that means I'm letting f of x equals 0, and I have to solve for x. The only way to do that is to factor this. So at Steel Canyon, we use what's called a t-chart. So these two values have to multiply up to the first term. So this should be x times x makes x squared. These two values have to multiply up to the last term. So what times what makes a positive 5? This case we'll do a positive 5 and a positive 1. You'll know you factored it correctly when you cross multiply, then add them together, you should get the middle term. So you should get x times 1, that's 1x, plus 5 times x is 5x. Notice 1x and 5x does make 6x, so it checks. So my factors are x plus 5 and x plus 1. Now that we have this factor, we can set each factor equal to 0 so we can solve for x. So on the top row, I would minus the 5 over, so my x-intercept is negative 5, 0. And then on the bottom row, minus the 1 over, so I get negative 1, 0. So those are my two x-intercepts. I can plot them on the graph. And then finally, to find the y-intercept, you would plug in 0 for x. So plugging in 0 and 0, you're left with your c value of 5. So your y-intercept is 0, 5. So on the graph, 0, 5. And because this has symmetry with the axis of symmetry, I can fold it over so it's going to land here. And now I can see my parabola. For the most part, though, we're going to use our calculator. So I'm going to start by showing you with the TI calculator, and then I'll show you with the Desmos graphing calculator. So starting off with our TI calculator, all of your graphing buttons are found at the top. You're going to go to your y equals, and you're going to type in the equation. So negative x squared minus 2x plus 8. There is a difference between the negative button, which is down here, and then the minus button, which is right here. So if you're naming it as the first number as negative, you hit this button. Your x is right here. So you negative x, and then squared is over here. Then minus 2x again, and then plus 8. If you hit enter, it won't show you the graph. Instead, on the right side, it says graph. When you hit that button, it'll slowly load and it'll open down. It should open down because your a value is negative 1, so it should be opening down. Notice this doesn't help you graph it on your paper though. So in order to do that, you're going to go second table. That way you can see the points on your table. You want this to show all of the points that you can fit on your graph. So that's anything between negative 10 and positive 10. So we're going to arrow up until you get to a point where this is off the graph. So notice negative 16 doesn't fit on our graph, so I'm not going to plot this point. But negative 5, negative 7 does fit. So when we go to our graph, I'm going to graph negative 5, negative 7, put a dot. Then negative 4, 0. For negative 3, it's at 5. And then negative 2 is at 8. Negative 1 is at 9. Then we have 0, 8, 1, 5, 2, 0, 3, negative 7. And then 4, negative 16 goes off the graph. It doesn't fit. So notice I'm just picking the numbers here that are between negative 10 and positive 10. Now that we have all of our points, you can play connect the dots to make your parabola. And without doing any work, I can answer all of this. So looking at the graph, my vertex is at negative 1, 9. So that is my vertex. Make sure you put it in parentheses. For your axis of symmetry, it's the line that goes through the vertex. So it's the equation x equals negative 1, because it's always the coordinate of your x value. And then for your x-intercepts, where does it cross the x-axis? Well, that would be at negative 4, 0 and positive 2, 0. You can see them on your table. And then for your y-intercept, it's where it crosses the y-axis, which is over here at 0, 8. And again, notice that's your c value. All right, so now we have this one. This time we're going to use the Desmos calculator in order to graph it. So I'm going to open up the Desmos graphing calculator. So it's just desmos.com calculator. So the equation is 4x squared minus 8x. So 4x, if you click this little thing, it lets you put the squared in. And then it was minus 8x. So you're just typing that in into here. And then when you click on the graph, you can see what the graph looks like. If you click on it, it lets you highlight, hey, look, the vertex is at 1, comma, -4. And then my x-intercepts, we have 0, 0, and we have 2, 0. So it does give us some points. But there's other points on this graph that I'd like to see. So if you hit this little settings button, you can go to the table. And you can scroll and see, okay, well, this is at -112, 0, 0, 1, -4, 2, 0. And that way it gives you kind of a sneak peek of what points you can add. So now that we know this, I'm going to go back to my presentation here. This is the table. So we can graph. -112 goes off just a little bit. So I'm going to put that in there. And then we have 0, 0, 1, -4, 2, 0, and then 3, 12. So now that we know what it looks like, our vertex was down here at 1, -4. Our axis of symmetry is the line that splits it in half. That's x equals 1. Your x-intercepts are the points on the x-axis, so 0, 0, and 2, 0. And then your y-intercept, where it crosses the y-axis, is 0, 0. And notice you don't have a c value, so that's why it's 0. All right, go ahead and give B a try. If this is the equation, what is the vertex? Use your TI calculator or your Desmos online graphing calculator. Okay, hopefully you were able to find that the vertex is 0, 4. Based on that, what is the axis of symmetry? Okay, so remember it's the x-coordinate of your vertex, so it should be x equals 0. What are the x-intercepts? Okay, on your calculator you should see that it's -2, 0 and +2, 0. And then finally your y-intercept. What is your y-intercept? Okay, you should get 0, 4. Notice that's your c value. So putting this together, you have 0, 4 as your y-intercept, x equals 0 is your axis of symmetry, your x-intercepts are -2, 0, +2, 0, and your y-intercept is 0, 4. All right, number 3 says the motion of a ball thrown is described by that equation where t represents the time the ball is in the air in seconds, and h of t represents the height in feet of the ball above the ground at time t. We're supposed to graph the function at right. To do this, I'm going to use the TI calculator again. So I'm going to go into my y equals. I'm going to type the equation in. I can't use the letter t though. My calculator wants me to use the letter x, so that's why it says x. If I was to hit graph, this is what I'm going to see. It goes way off the graph, so that's not really helpful. So instead I'm going to go second table so I can see my table. Notice that we have time starting at 0 seconds. Notice the height of the ball is at 192 feet. So at 0 seconds, we're at 192 feet. And then at 1 second, it's at 240. And then at 2 seconds, at 256. And then 3 seconds, we're back to 240. 4 seconds is 192 again. And then at 5 seconds, it's at 112. And then at 6 seconds, the height is 0. So that is the curve that the ball is traveling. So what is the initial height in feet of the ball? So you should notice that the ball started at 192 feet. And then what's the maximum height of the ball? So the highest that the ball goes is up here at your vertex, which was 256 feet. Part D says, when does the ball hit the ground? That would be after 6 seconds. And then finally, during which interval does the ball rise? Well, it's rising from 0 seconds to 2 seconds. And then when does the interval have the ball falling? Well, it's from 2 seconds all the way to 6 seconds the ball is following.